Hey everyone, the lesson notes are a little bit different today. So if you have a printer at home, that's awesome. I would go and print out this assignment. If you don't have a printer at home, it's going to be a little bit harder for you, but you can still follow along and do things, but you're going to have to draw a bunch of graphs for this, um, which is why I have it printed out. So anyways, our lesson title today is 4.5b, parallel and perpendicular lines. So make sure that you write that down. This means students will be able to, so by the end of this lesson, you should be able to graph parallel and perpendicular lines by discovering the relationship between the slope of a pair of lines. So let's start off here for right now. We have line A. We're going to say that line A is y equals 2x minus 3. We're going to say that line B is y equals 2x plus 1. And then for our line C, we're going to say y equals 2x. Now let's go ahead and identify what our slope, our m, and what our y-intercept, our b, are. So I know that these equations are in the form y equals mx plus b. So that last number there is my b. So that says -3. This says +1. And then this, there's nothing there. But I can always add in a +0. So that's what I'm going to do to get my b for that last equation. M is a little bit harder to see. It's whatever's connected to the x. It's the coefficient of the x. So if we look at this, it's 2. If we look at this, it's 2. And then line C, the coefficient is also 2. So let's go ahead and now that we have our m and our b put out there, we're going to graph those. So when I'm graphing, I'm looking at line A. Line A is going to be starting at -3. So I'm going to do a dot at -3. I know that my slope is 2. That technically means up 2 over 1. We're going to go in a positive direction, which means we're going up and right. So up 2, right 1. Up 2, right 1. I typically only make you do 3 points, but for the purpose of today's lesson, I'm going to want you to go all the way through from one end to the other of your graph, just like how I did here. That's going to make it a little bit easier to see what's happening because we're talking about parallel and perpendicular lines. If I graphed these 3 points for this first line, and I had another line over here, I wouldn't be able to see if it's parallel or perpendicular as easily because that line doesn't go all the way through my graph. So for the purpose of this, make sure you're doing that. I have all my dots pointed or plotted for that first line, so I'm going to go ahead and just connect them. And that means that line A is officially graphed. So that's in blue. Let's do line B. I'll do that one together, and then I'm going to pause the video for line C just to save on some time. So again, we're starting at +1. So +1 is right here. It's up 2, and remember we can add that over 1 on the bottom. So it's up 2 over 1. And just like before, I want you to go all the way through the coordinate plane, and that's the graph. After you get all your points plotted, you're going to draw your line, connecting all of them. And so line B is done. Give me a second to do line C. And there's line C. So what I want you to do is I want you to look at these 3 lines. Would you call these anything specific? Hopefully you're thinking that these are parallel lines. So since they're all parallel, I want you to look at those slopes. What do you notice about their 3 slopes? hopefully you see that they all have a slope of 2 and that they end up as parallel lines. I want you to think right now, what would be an equation of a line that's parallel to A, B, and C? So I gave you 3 lines that are parallel to, oh my gosh, that are parallel to each other. I want you to try to come up with a 4th line that might be parallel. You can even graph it on the same coordinate plane to see if it works out. So try to come up with your own line. So hopefully you've thought of something. Honestly, as long as you have the same slope, so in this case, it's a coefficient of 2, our slope is 2, and then a b that has not been used already, you're going to have a parallel line. So in this box right here, or just make your own statement, I want you to use your own words to write a sentence or two about the conclusion we made about parallel lines. Hopefully you came up with something like I have written here. I said parallel lines have the same slope in different y-intercepts. So an equation could be y equals 2x minus 1, because that hasn't been used, and it has the slope of 2. So what I want you to do now is, let me scroll down. I want you to try these 4 problems. So they're multiple choice. Hopefully they don't take you too long, and you can do most of them in your head. So try those 4 problems now. Okay, so let's go over the answers. So for number 1, you should have gotten D. Number 2 is also D. Number 3 is A. And number 4 is also A. So for these bottom 2 problems, I noticed that they're in standard form to start off with. We need to have these in slope-intercept form so we can see our slopes, because it's important for us to see our slopes for these types of problems. So I'm going to draw my line, and my goal is to get y by itself here, because I want to make this into a slope-intercept form. I'm going to start off by moving over that 6. Since it's a positive 6, I'm going to be subtracting 6 from both sides. That gets rid of that and leaves us with a 2y, there we go, equals, can't put those 2 together, so we're just going to write them next to each other. So that's a negative 6x and then plus a positive 12. Next thing we need to do is divide by 2 because we want to get rid of that on our y. And I'm going to divide every term by 2. So negative 6 divided by 2 gives me a negative 3, and I keep my x. And then 12 divided by 2 is 6. And so this is my equation here that I'm working with. I noticed that the slope is a negative 3, which is why I answered it as negative 3 over here. You would go through that same process over here and then figure out that this is your slope. So as long as it has a different y-intercept, you're good to go. I've got 2 more problems for you to try. I want you to write an equation that is parallel to this line here. And you're also doing an equation that is parallel to that line there. Again, just like before, since this is in standard form, we can't work with it. So make sure you're converting it to slope-intercept form, just like how I did on that previous problem. Once you're done, go ahead and graph those 2 lines to prove that they are parallel. And here's your answers. So this is just one possibility. You could have chosen a bunch of different things. Just make sure that it's the same slope. So since this says 2/3, I wrote 2/3 x. And then I can pick any y-intercept I want. So this time I chose -1. I graphed those 2 lines and they are indeed parallel to each other. So the red line represents that top one and the green line represents the one that I wrote. Over here, I took the equation that is in standard form and I converted it to be, or I rewrote it to be in slope-intercept form. So in slope to intercept form, I notice that the slope is 3/5. So I wrote y equals 3/5x because that has the same slope as our original equation. And then I did a +0 for my slope, or my y-intercept. And so since it says +0, I don't actually have to write it. So I graphed those two equations, and they are both parallel to each other. Let's move on. So now I'm going to give you new lines, and I want you to graph them and compare them. So let's start off with line F. So with line F, we're going to say that it's y equals 3/2 x plus 1. And we'll say that line G, I'm going to switch colors. Line G is y equals -2/3, that was a rough 3, sorry, x plus 5. So let's go ahead and identify our y-intercept and our slope for both of these equations. So for this first one, we go to a neutral color, we'll go blue. For our y-intercept, that's always that last number there, it's a +1, so B is +1. For line G, B is +5, because it's that last number there. Our slope for line F is a +3/2. And then for line G, it's a -2/3. All right, let's graph those equations. So let's start off with line F. Line F tells me to start at 1. So my y-intercept is 1. And then I'm going up 3, right 2, because this is a positive graph, so it needs to go this direction. So up 3, 1, 2, 3, over 1, 2. And I'm going to go until I reach the end. And then I'm going to go the other way. Down 1, 2, 3, over 1, 2. 1, 2, 3, over 1, 2. And that's as far as I can take it, so I'm just going to draw a line that roughly connects those dots together. There we go. Now I'm going to do the same for my other equation. So we are starting off with 5 because that's our y-intercept. So that is up here. And then this time, since it's a negative, we'll go down and to the right because I want this kind of a slope. So 1, 2, 1, 2, 3. That was our slope. 1, 2, 1, 2, 3. Up 1, 2, 1, 2, 3. Now I'm going to draw my line that connects those. And we have our two equations graphed, or our two lines. So what do you notice about these two lines? Hopefully you're thinking that they're perpendicular, and you would be correct. These two lines are perpendicular. We would have to check to see if they're perpendicular by using a protractor and measuring the angles. So think about perpendicular lines and what you know about them. What is special about their angles? Hopefully you're thinking that they're all 90 degrees. So this line, that green line, crosses the red line at a 90-degree angle. So look at their slopes now. Are they the same? Or are they different? Hopefully you notice that this slope is not that slope. Those are two different numbers. Think about how they're different. If you don't see it yet, that's okay. Think about how these two slopes are different from each other, because there's a pattern that goes along with that. Let's give you lines H and I to see if you see that pattern. So I'm going to give you these two lines, and I want you to graph them. You can use the same graph here, just make sure that you're looking at lines H and I, not F and G. So let me pop those on there. And there's your two equations. So for line H, you have y equals 2x minus 6. And then for line I, you have y equals negative 1/2 x plus 3. So graph those two and figure out what our slope and what our y-intercept is. Pause the video now. And here's your answers for those two equations. So hopefully you got about the same thing. So I've got my graph shown on the left there, and I want you to look at the slopes of these two lines and those two lines. So lines F and G, and then lines H and I, and see what you see. We know that both of those sets of lines represents perpendicular lines. So line F and G are perpendicular, and line H and I are perpendicular. So I notice that, let me get my pen, and we'll do black, there we go. I notice that this is a positive number, and this is a negative number for our slope. This is a positive number, and this is a negative number. So that's important. One's positive, one's negative. And then what I also notice is this is 3 over 2, and this is 2 over 3. This is 2 over 1. This is 1 over 2. So all of these equations, or all the slopes, get flipped. So they are opposite signs, and then that flip has a special name in mathematics. That word for flip is called reciprocal. So, in conclusion, perpendicular lines have slopes that are opposite reciprocals, opposite meaning that we change the sign, and then reciprocal means that we flip our fraction. So opposite, change the sign. Reciprocal means flip the fraction. And then it's also important to note that the y-intercept does not matter. So if they have the same y-intercept, that just means that they cross at our y-intercept. And that's okay. So now I want you to fill out this table here of opposite reciprocals. So we talked about that word opposite reciprocals, and this takes you through the process of doing that. So I want you to come up with a bunch of slopes. If you can't think of any, or you don't want to come up with a bunch of slopes because that's a lot of decision making, I will pause the video and add those in right now. So the ones that I put on there give you a good diverse selection. You can always look back at this example that I have written out for you. So whatever you start with, make it a fraction, then flip your fraction, and then change the sign, and that's going to be the opposite reciprocal. So if I had an equation that had a slope of a -4 and I had a different equation with a slope of 1 over 4, those two lines would be perpendicular to each other because that slope is the opposite reciprocal of this one over here. So pause the video, try out these things. If you selected these couple, you can see the answers at the end. And here's your answers for that. So go ahead and double check them and see how well you did. Hopefully, if you made up your own starting slopes, then you can go ahead and kind of just double check to see if you followed the correct procedure. So let's try a couple of more problems. So I've got 4 up here for you. I want you to try them all. They all have to do with perpendicular slopes. So which equation would be perpendicular to that? Remember, you're looking for the slope that has the opposite reciprocal. And then for these two down here, they are in standard form, so you need to convert them to slope-intercept form first. So pause the video and try those. So for number 9, hopefully you decided that that was C, because since that's a positive, we know we have to have a negative slope, which eliminates B and D. And then we know that we have to flip it. So since that's a 7 and that's a 7, I know that A can't be my answer. This I know can be written as 7 over 1, so that means 1 goes on top, 7 on bottom, so C is our answer. Number 10 is B. Number 11 is C. And number 12 is also C. For number 12, you could have also said D, because D is just another way to write that same equation. Oh, just kidding. Backtrack. Sorry. Ignore what I said. That is the same exact equation as that, so that would not work. If you look at these, you might notice that some are parallel, some might be perpendicular, like C is, and then some just don't have any relationship at all. They're just two lines that intersect. And that's an important concept for our homework today. So when we start getting into that, I'll talk a little bit more about that. Now I have these two problems, 13, 15, 14, and 16. Sorry, that was out of order. But you're going to be writing an equation that's going to be perpendicular to this line here, and then you're going to be proving it by graphing it, just like how you did before. And here are two possible answers for these problems here. So I noticed that my slope for problem number 13 is 6. So that means that I do the opposite. So since this is a positive, it is now a negative. And then I flip it. So since it's 6 over 1, it's now 1 over 6. Graph to prove, and it looks pretty perpendicular. Next one, I can't be working with this in standard form, so I converted that standard form to slope-intercept form, and notice that my slope is -1/2. So what I did next was I got rid of the negative and turned it into a positive because that's the opposite, and then I did the reciprocal of 1/2, so I flipped it, and that became 2 over 1, which simplifies to 2. I can pick whatever y-intercept I want. It doesn't even matter. So for this one, I picked a y-intercept of 0. And then for this one, I picked a y-intercept of -1. So now we're into the practice problems for you. So I've got 4 problems here where I would like you to identify the slope and the y-intercept. Hopefully these will be kind of quick for you. All you have to do is take the equation that's in standard form and convert it to be slope-intercept form. And then you can easily see the M and the B. The only one that might be a little bit tricky is this last one here, because this has a coefficient of 0. So let me start you off with that problem. So since we have 0 times y, I'm smart and I know that 0 times anything is 0, and so hopefully you're smart too, because you guys are all amazing, so you better say yes. So 0 times anything is just 0, and then we've got 3x plus 0, which we're all smart. We know is 3x. Can't trick us. And then that's still equal to 21, because I haven't done anything to that side. Next thing I'm going to do is get rid of that 3, because I'm just at this point solving for x. So that makes that go away, and we're left with an x equals 21 divided by 3 is 7. Well, that's not like any equation that we have. So what I would personally do is just draw a little bit of a graph over to the side, and then draw the equation, or draw the line where x equals 7, and tell me what the slope and the y-intercept is there. Reminder, we have more y-intercepts, or we could not have a y-intercept. That's a possibility. And then for our slope, there's more than just the numbers. There's something that, if you remember from 7th grade for sure, and then we talked about it a little bit in this class, there's another possibility for your slope for that one. For this one, it doesn't, the y-intercept doesn't simplify to a nice number. So if it doesn't simplify to a nice number, just keep it as a fraction. All right, let's move on. So I was talking to you a little bit earlier about parallel, perpendicular, and neither. In this case, I give you 2 equations to compare. So what I need you to do for these problems is get them into the same form. So you notice that this one's in y-intercept form, and this one here is in standard form. So I'd convert that standard form to y-intercept form. And then you're comparing those two slopes to determine if it's parallel, perpendicular, or neither. Make sure you follow our rules that we've talked about before. So if it's parallel, it has the same slope and different y-intercepts. If they have the same slope and the same y-intercept, it's just the same line. It's not parallel lines. They are the same exact line. Perpendicular, doesn't matter what the y-intercept is there, but you have to have opposite reciprocal slopes. Neither is anything else that you run into. So you will have problems that are neither. And then on a few of these, I think there's 4 of them, you're going to be graphing to prove your answer. Once you get down here, you don't have to graph anymore, you're just circling one. The last, 6 problems, you are finding the slope of a line that's parallel or perpendicular to the equation that I gave you. So you're coming up with those slopes. Hopefully this homework doesn't take you super long. I know that the notes took me a ton of time, but this homework at the end wasn't too bad. These ones are pretty quick. These ones take a little bit of time, but they're honestly not that bad. So if you have any questions, just send me an email and I'll help you out.